Greetings, fellow mathematicians, and welcome back to the Art of Integration. We're going to take a look at an interesting way to find an antiderivative for secant of x using Weierstrass substitution. Now, before you go through this video, make sure you're comfortable with Weierstrass substitution, t equals tangent of x over 2, and the conversions for dx, sine of x, and cosine of x. I'm going to have that link down below in the description, so make sure you're comfortable with that before you go through this problem. In your Calculus 2 course, you probably found the antiderivative for secant of x by using a trick, multiplying and dividing by secant x plus tangent x. Now, that's the standard approach. It works. With a little bit of rewriting, it becomes a straightforward u substitution. Substitute u as secant x plus tangent x, and you get a very simple antiderivative to calculate 1 over u. That'll integrate to natural log of u, back substitute, and you get your antiderivative natural log of secant x plus tangent x plus c. Now, I don't like this when I go through my Calculus 2 course because that trick kind of comes out of nowhere. So we're going to take a look at an alternate approach, a little bit more straightforward, with Weierstrass substitution. Weierstrass substitution is typically used when you have an integral involving combinations of sine and cosine. Now here we have secant of x, so for our first step, let's go ahead and rewrite this in terms of cosine. We can rewrite secant as 1 over cosine of x, and at that point we can make our substitutions for cosine of x and dx in terms of t. So if you go ahead and do that, be careful, you have cosine of x in the denominator. So we're going to get 1 minus t squared divided by 1 plus t squared in the denominator. And don't forget to convert dx. That becomes 2 divided by 1 plus t squared dt. From there, you can take the 1 plus t squared, distribute that to the other denominator. That'll knock out and cancel those factors out. And you'll get a very simple integral in terms of t, 2 divided by 1 minus t squared. And that, you might recognize, you can factor the denominator. Simple difference of squares. Right, that is 1 plus t times 1 minus t. And that should be straightforward to go through a partial fraction decomposition. I have the work for the partial fraction decomposition over on the side there. Make sure you're comfortable with that. You have 2 linear factors in the denominator, so you'll get 2 partial fractions, and should be straightforward to solve for the values of a and b, both of which come out to equal 1. If you go ahead and plug that back, you get 2 simple integrals here, an integral involving 1 divided by 1 plus t, and another integral of 1 divided by 1 minus t. The first one, that'll be straightforward. You'll get natural log of 1 plus t. And just be careful with the second term there. You do get a natural log, but technically you'll want to do a substitution. You get an extra minus. Notice in front of t, in that denominator, there's a factor of -1. So this will come out to give you natural log of 1 minus t. And there we go. Now at this point, we want to convert our antiderivative, the answer here, from t back in terms of the original variable, which is x. Now let's go ahead and do that. Recall that the Weierstrass substitution that we used was t equals tangent of x over 2. So we're going to plug that in both spots there. And we get our antiderivative in terms of x as natural log of 1 plus tangent of x over 2, and then minus natural log of 1 minus tangent of x over 2 plus c. And that is correct, but notice it does not look like the standard answer you get in a Calculus 2 course. It doesn't look like the answer, natural log of secant x plus tangent of x. So let's go back to the original conversion there with t, and let's try to rewrite that rather than converting directly to x. First, we're going to use some properties of logarithms to combine these together to a single logarithm. This will come out to be natural log of 1 plus t divided by 1 minus t. And from here, again, you could substitute t equals tangent of x over 2, the Weierstrass substitution, but that's not going to give you the answer that we're looking for, natural log of secant x plus tangent of x. So we're going to make use of a creative trick, one that we've used already throughout the art of integration. We're going to multiply by 1. So inside that logarithm, we're going to choose 1 in an appropriate form. We have the original inside there, 1 plus t divided by 1 minus t. And to convert back, you might recall the conversions for sine of x and cosine of x in terms of t involve 1 plus t squared and 1 minus t squared. So let's try our trick here of multiplying by 1 in the form 1 plus t divided by 1 plus t. And from there, if you multiply the denominators inside that logarithm, you'll get 1 minus t squared. And just be careful with the numerators inside the logarithm. You have 1 plus t times 1 plus t. Be careful to multiply that out, and you'll get 1 plus 2t plus t squared. And from there, we're going to split apart the terms in the numerator into 2 separate fractions. This is all still going to be inside that single logarithm. I'm going to rewrite this as using the terms 1 plus t squared. That'll be over 1 minus t squared. And then we have the other part from the numerator, 2t. That'll be over 1 minus t squared as well. Now, it's going to be very easy to convert back to x. With a little bit of foresight and being familiar with your conversions from the Weierstrass substitution for cosine of x and sine of x in terms of t, you might be able to see that the first fraction inside the log, 1 plus t squared divided by 1 minus t squared, that actually converts to 1 over cosine of x. The second fraction, 2t divided by 1 minus t squared, that converts to sine of x divided by cosine of x. So we're going to identify this as 1 over cosine of x, and this fraction, that converts to sine of x divided by cosine of x. And at that point, we're going to recognize those combinations as other trig functions. 1 over cosine of x, that is secant of x. And you all know sine of x divided by cosine of x, that is tangent of x. And we get the familiar antiderivative for secant of x, which is natural log of secant x plus tangent of x. Hope you enjoyed this video in our ongoing series, The Art of Integration, where we're all about creative ways to evaluate integrals. If you enjoyed the content, make sure to like and subscribe.